All right, calculus here. We have a little video for your Friday the 11th. What I'm going to do first is I'm going to give you some help on this homework sets. Chapter 3. Go Dogs. All right, homework set 3. Chapter 4. We ain't going to edit that out. Take a look at number 3. So 1 through 4, say find the absolute max and absolute min of f on the given function. So f of x is equal to x minus natural log x. We take the derivative, which is 1 minus 1 over x, set it equal to 0. Do a little cross multiplying, we get x equals 1. Note that, yes, x equals 0 makes the derivative undefined, so we would think that would classify as a critical number, but 0 is undefined in the initial function, also out of the interval as well. But it doesn't count as a critical number because it is gives me a value of x that makes f of x undefined. So x equals 1 is my only critical number. So I come over here, I take f of 1/2, f of 1, f of 2, find out those values. Again, plug that into the original. And I see that f of 1 is my minimum, and f of 2 is my maximum. Just plugging that in, all right? So if you're gonna be precise, you can say absolute max at 2 comma 2 minus natural log 2. That's fine. Absolute min is at 1, 1. Now I think we've done one like this in our notes. Derivative of 2 cosine x, negative 2 sine x. Derivative of sine 2x is cosine 2x times 2, or 2 cosine 2x. I move the 2 sine x over, and I divide by 2. So I'm looking in the first quadrant. Sine and cosine are coterminal. So if x is 30 degrees, or pi over 6, sine of 30 is equal to cosine of 60. All right. So that's my answer. Sine of, or x equals pi 6. Coterminal, x equals pi 6. You can try like plugging in pi fourths for x, plugging in pi thirds for x. You do not get the statement of equality. So f of 0, f of pi 6, my critical number, and f of pi over 2. You can see the work. I have an absolute max at pi 6 comma root 3 plus root 3 over 2, or 3 root 3 over 2. An absolute min at pi half 0. I'm pretty sure we did this in our notes. But that's how you handle 4. 5 through 8, find the critical numbers for each function. So I'm going to do 7 with you. Low d high minus high d low, all over the square of what's below. Be very careful when you're subtracting. All right, now, first off, the denominator is never 0. You get plus or minus 2i. Wouldn't matter, wouldn't count as a critical number when the denominator is 0 there, being x squared plus 4, because it already makes the original function f of x undefined. But x squared plus 4 cannot become 0. So I had a negative x squared plus 2x plus 4 equals 0. I've divided everything by negative 1. That's how I got x squared minus 2x minus 4 equals 0. That takes the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I get 4 plus 16, which is 20. 2 plus or minus root 20 over 2. All right, those are nice numbers. I don't have to look at some interval. I'm not looking to minimize or maximize anything. That looks good. All right. Take a look at 10. Verify the function, satisfy the authority. So you don't have to do that. You just got to show me that f of a equals f of b. And then find all values c that satisfy Rolle's theorem. Rolle's theorem is a special case of the mean value theorem, which says the derivative evaluated at c, f prime of c is equal to the slope of a straight line from a to b. If f of 0 is 0 and f of 16 is also 0, then the slope of the straight line from a to b is 0. So that's why we could say f prime of c is equal to 0. So show that f of a is equal to f of b on 9, 10, and 11. So I need to figure out what the derivative is. So I got x to the 1/2 minus a quarter x. That means f prime of x is 1/2 x to the negative 1/2 minus a quarter, which is also 1 over 2 root x minus a quarter equals 0, which is 1 over 2 root x equals a quarter. Do a little cross multiplying. I got x equals 4. X equals 4. We're going to handle 12. 12 is very much like 13, which I'm going to do with you. Verify that the function satisfies the hypotheses of the mean value theorem. It's continuous and differentiable on the interval -3 to 1. Then find all values of c that satisfy the conclusion of it. All right. So this is saying, again, mean value theorem is f prime of c. The derivative evaluated at some c has the slope of that tangent line has the same slope as a straight line from A to B. So f prime of c is equal to the slope. You can say that kind of in layman's terms. F of -3 is a -9. F of 1 is 7. So the slope from A to B is not 0. 7 minus a -9 over 1 minus a -3 is 4. The slope is 4. So we're saying that the derivative, chain rule time, 3u du dx. 3u squared du dx is what I mean. So it's 3 times x plus 1 squared is equal to the slope, which is 4, divided by 3. Take the square root. X plus 1 is equal to plus or minus square root of 4/3. And they both fit in to the interval -3 to 1, believe it or not. That -1 there makes all the difference. You get like -2 point something and then 0 point something. They both work. All right, let me help you with 15. Again, f prime of c is equal to the slope. F of -1 is 3 over 2. F of 1 is a -5 over 2. -5 over 2 minus 3 over 2 divided by 1 minus a -1. Slope's a -2. Now this is a parabola, so we won't be shocked when we get 0, right? From A to B. Something's interesting going on. We'll have to investigate the parabola there on Desmos. So f prime of x is x minus 2, and that equals the slope from A to B. And we get x is 0. Fits right in between there. Gotta look at that graph. 17 through 20, find where each function is increasing or decreasing. So, when in doubt, take a derivative and set it equal to 0. So 0 is equal to the derivative. I factored out 6. Then I factored that derivative. Got two critical numbers of -4 and 1. I go over here, -infinity, -4, -4 to 1, 1 to infinity. Test numbers, those should be over, -5, 0, 2. And what does that make the derivative? So if I plug in -5 in for x, I have a negative times a negative, which is a positive. If I plug 0 in for x, literally there, -24, or a positive times a negative, which is a negative. And if I plug 2 in for x, I get a positive times positive, which is positive. So f of x is increasing on the interval -infinity, -4, union 1 to infinity, and it's decreasing on -4 to 1. That's all we need. Now 17, 20 you don't really need calculus for, because we can find that out from algebra 2, -b over 2a, or taking a derivative and set it equal to 0. So 5 over 2 is the turning point there, -infinity to 5 over 2, 5 over 2 to infinity. It makes a u, so from -infinity to 5 over 2, we can see it's going to be decreasing. From 5 over 2 to infinity, it is increasing. So you can kind of see the same thing there on 17. I would not expect the parabola on a quiz, but those are nice to have on a homework assignment. All right, 21 through 25, this is the big one. Find it all. Find it all. So take my derivative and set it equal to 0. Factor out the 3. Then factor it. 3 times x minus 3 times x plus 1 is 0. X is equal to -1. X is equal to 3. -infinity, -1. -1 to 3. 3 to infinity. My test numbers of -2, 0, and 4. Plug -2 back into my derivative. A negative times a negative is positive. Plug 0 in. A negative times a positive is a negative. It's exactly -9. Put a +4 in, you get a positive times a positive, which is a positive. So it's increasing on the interval -infinity, -1. Union 3 to infinity. It's decreasing on the interval -1 to 3. Got a local max at -1, comma, you can plug -1 for x. It's got a local min at 3, comma, you can plug 3 back in for x in the original function. So now, here's my second derivative work. If my first derivative was 3x squared minus 6x minus 9, my second derivative is 6x minus 0. And I get x is equal to 1. So the tangent line, changing direction, right, it is going to go from concave down to concave up. -infinity, -1, or to 1, and then 1 to infinity. I'm going to use 0, and then 2. Plug 0 in for x, you get a negative. Plug 2 in for x, you get a positive. Concave down on the interval -infinity to 1. Concave up on 1 to infinity, so you have an inflection point at 1, comma. Plug 1 in for x. Oh, can't see my finger. 1 in for x. All right. We can take a look at the graphs and show the second derivative and first derivative and what that means. Some of you are asking. Those are really good questions. All right. Let's take a look here at 25, and that is your homework help. This is due on Monday, so let's work hard on it. First derivative, 12x squared minus 6x. Factor out these 6x. You get critical numbers of 0 and 1/2. -infinity to 0, 0 to 1/2, 1/2 to infinity. Test numbers of -1, 1/4, and 1. I'm plugging it in right here. If you plug -1 in, you have a negative times a negative, which is a positive. Plug in 1/4, you have a positive times a negative, which is a negative. Plug in 1/2, you have a positive times a positive, which is a positive. It's increasing on the interval -infinity to 0, union 1/2 to infinity. It's decreasing on 0 to 1/2. There you go. Local max at 0, 0, and a local min at 1/2 something. Anyway, that was my first derivative. I am now going to take the second derivative, set it equal to 0. Something's happening at x equals 1/4. -infinity to 1/4, 1/4 to infinity. I got a test number of 0, test number of 1. Plug in 0 in for x, your second derivative is negative. Plug 1 in for x, your second derivative is positive. Concave up on blank, concave down on blank. You have an inflection point at 1/4, comma. Plug 1/4 in for x, you're going to get a fraction. All right, so I just did 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 40% of your homework I just did with you. All right, so you're welcome. Go from there. Now, we need to talk because you're going to feel pretty confident that you're going to do your quiz on Wednesday. Next Wednesday, that is fair. There's a potential that your test gets moved a little. I don't really want to rush through optimization. And I want to go over, it might just move a day. It might just be on the 24th and 25th. All right, this is 2 days to review. Anyway, start looking at this quiz review. Start looking at your exam review as well. So we should be able to handle 1. You should look at 1 and 2 right now. Okay, maybe you wait for 3 and 4 with me, but 1 and 2 should be no big deal. Find the critical numbers of the function. We can do that. Again, we wouldn't count. If I put that in video before, where like x equals plus or minus √5 is a critical number, it is not, though it will make the derivative undefined, it is not allowed. So plus or minus √5, not a critical number. This could not be easier. Number 6. Rolle's theorem, just plug 0 in for x, 36 in for x, show that you get the same number. Plug -6 in for x, -2 in for x, show that you get the same number, i.e. y value, and take the derivative and set it equal to 0. All right, mean value theorem. Take the derivative and set it equal to the slope of the line from there to there. You can do 9 and 10. Maybe you wait for on 11 for me. And then find the intervals of increase. Find it all. Find it all. So, 12, 13, 14 should be pretty good. You might want to wait on 15 for me. Anyway, folks, there it is. Please be productive on Friday and this weekend so we can have a good week next week. That is all. This is Yak Math Videos. We are signing out.